Hey folks, we're going to be doing combining like terms here, and you're going to want a calculator for at least the first part. So pause the video if you don't have the calculator, and then come back. Okay, so combining like terms is a huge thing in algebra, and it's all based on number patterns. So let me just give you a number pattern here, and you can decide if it's true or false. So let's say I have 4 times 2 plus 3 times 2. I'm wondering, does that equal 7 times 2? So pause the video, see what you think. If you can do it in your head, great. Okay. It's going to turn out that that is true. Now, I'm going to change the number inside the parentheses and leave everything else the same, and you can see if it's true or false again. So instead of a 2, let's use 5. So we'll have 4 times 5, 3 times 5. I'm wondering, does that equal 7 times 5? So see, true or false, and then hopefully you got that it was true. So you might be sensing a pattern here. Let's just do one more. I won't belabor the point. Let's try 4 times 10. Okay, we'll put in a different number. 3 times 10, 7 times 10. Is this true? This one is easy, right? It's 40 plus 30. Does that equal 70? Does, right? So we definitely have true, and so at this point, I'm going to spare you the rest. The mathematician is going to notice a pattern, because here's the thing. It's going to work for any number you put in the parentheses. I don't care what number you put in. Negative, decimal, won't matter. 4, 3, and 7 is always going to be true. So you can describe that pattern verbally using words. You can say, oh, guess what? If you take some number, I don't care what it is, if you do 4 times that number plus 3 times that number, you always get 7 times that number. And that's great. Verbal is great. Mathematicians use algebra to describe patterns like that. So a mathematician would write it like this. They would say the pattern, hey, you know what? Let's just let x be any number. Then guess what? If you do 4 times that number plus 3 times that number, guess what you get? Guess what you get? You get 7 times that number. And folks, if you understand this, you have just combined like terms. Because 4 times the number plus 3 times the number is always going to equal 7 times the number. And that isn't all. You can change those coefficients around. Instead of a 4, 3, and a 7, you can do a 6x plus 2x. And guess what you're going to get over there? 8x. You see the pattern that's going on here? You're just taking the 6 and the 2 and adding it. It works with subtraction too. So if you had 6x minus a 2x, guess what you would get? 4x. Look, that is almost all I need you to know about combining like terms. There is one thing that confuses kids, so let's address it. So if you understand this, great. I'm going to erase for a sec so we can try one more thing. Let's say instead of 4 times 2 plus 3 times 2, let's just leave this as a plus 3. And my question is that still a true statement? So pause the video if you need to. Hopefully you just discovered it is false. This is 6. I'm sorry, this is 8. 8 plus 3 is 11. But this is 14 over here. So there is no pattern here. If a mathematician, a rookie mathematician, said, oh, I see the pattern. If you have, and let's say you have any number here, if you do 4 times that number and then add 3, guess what? Guess what? You get 7 times that number. Well, sorry, bogus. It's not right. That is not a pattern that works. We just proved it up here. But sometimes kids will do this. Turns out this 4x and this 3, they are not like terms, is what they call them. Like terms can be added. If we had 4x and we added it to that 3x, then hey, yeah, go ahead, write 7x there. But this, no way. 4x plus 3 cannot be simplified. It's as simple as it can get. Okay, well, let's just take it all the way. What makes for like terms? What makes terms like or not like? You may have already been realizing it here. it turns out, as far as our purposes go, you'll get some fancier definitions as you go higher in math, but as far as we know, all you need is this. If they have the same variable next to them, like an x here and an x there, you got like terms. They can be combined. So if I give you something like, hey, what is 10x minus 7x? You can combine those. They got an x here and an x there, so that's just going to equal 3x. But if one of them doesn't have an x, like if we had 10x minus a 7, those are not like terms. They can't be combined together. That's as simple as it gets. I mean, you could write, if you want, you could write, oh, it equals 10x minus 7, but that's as simple as you could make it, okay? I guess one last wrinkle. I've been using x, 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 x here. It doesn't matter what letter you use here. You could be using A's, B's, or T's, or whatever. So sometimes, I just don't want you to get confused if you see a different letter. So let me just do a couple like that. If you have 4n plus 10n, guess what I'm going to write down? They're like terms because they have the same variable. That's going to be 14n. I guess you can even like do more than just two terms here because that actually you should know that. So let's do this. Let's say I have 4n plus 3 minus 1n plus 8. Okay, well, that's a 1 there, sorry. Let me just make sure you know that's a 1. How do you deal with this? With addition and subtraction, they are at the same level at PennBest, so you can do them in any order. So what I usually recommend is underline the terms of the variable to keep them straight, because they are like terms. So this has a variable, I'm going to underline it. This doesn't have a variable. This does, so I'm going to underline it, and I recommend include the sign so that we remember that this is a negative. This doesn't have a variable, so I'm not going to underline it. And then, in our class, all you're going to have left are constants, okay? So this guy, I'll double underline it, this guy, double underline it, and I'm underlining the sign also. And this just makes makes the like terms pop a little bit more, so I can kind of like tell readily, hey, which ones can be combined with which other ones. So I have a 4n here minus a 1n. So guess what? 4n minus 1n is 3n. Okay? And I have a positive 3 here, and I'm adding an 8, so that's a positive 11, right? So I'm going to write, oops, run out of the screen here. I'm going to write plus 11. And it's kind of nice, right? Like, you had something that was sort of complicated, and you just boiled it down to 3n plus 11. Oops, 3n plus 11, okay? That's how you combine like terms.